This is Help with Vertical Motion model. In this video, we're going to look at when an object is dropped and figure out how much time it takes for the object to reach another destination. For this, we're going to use the equation h equals negative 16 t squared plus s, where h is your ending height, t is your time, and s is your starting height. So if we look at the problem, Mary is 64 feet in the air. If she drops the ball from that height, how long will it take to reach the ground? So ending height is 0 when it touches the ground. Starting height is 64 feet. If I plug everything into the equation, I now have 0 equals negative 16 t squared plus 64. Now we're at the point where there's 3 different ways we could solve this. Way number 1 is we could just use algebra to solve it. So if I rewrite the equation right here, what I'm going to do is isolate the t squared. So I'm going to move 16t squared to the other side. I'll add it to both sides. Positive 16t squared equals 64. Divide both sides by 16. T squared equals 4. And if I take the square root of both sides, I need to remember that there's 2 possible answers. T could equal positive 2, or t could equal negative 2. That's where I go back to the story problem and I ask what makes sense. In this case, it doesn't make sense for the ball to travel negative 2 seconds. We generally don't talk about it like that. So my answer is going to be, it takes 2 seconds for the ball to reach the ground. The second way we can solve this is we can use the quadratic formula. So I'm just going to rewrite the equation right here. It's already in standard form, so I don't need to worry about moving anything. I identify a, b, and c. A is negative 16 t squared. B is usually the number in front of the t, or the variable that just has a power of 1. Since there's nothing here, we're going to use 0, and c equals 64. So then I'm going to plug it into the equation. T equals negative b plus or minus the square root of b squared minus 4 times a times c. And I just noticed that I wrote this down. Please don't write the t squared. A, I'm just looking for the coefficient in front, so I just want negative 16. Finish up the rest of the quadratic equation. This is all going to be over 2a. So I have t equals negative 0 plus or minus the square root of 0 squared minus 4 times negative 16 times positive 64 all over 2 times negative 16. First, in order to simplify everything, I'm going to clean up what's underneath the square root. So I turn to my calculator, type in 0 squared. You don't have to, but you can. 0 squared minus 4 times negative 16 times 64. And I get 4,096. So t equals 0 plus or minus the square root of 4,096 all over, if I clean up the denominator, 2 times negative 16 is negative 32. From here, I'm going to divide the equation into 2 separate equations because of this plus and minus. So now I have t equals 0 plus the square root of 4,096 all over 32, and t equals 0 minus the square root of 4,096 all over negative 32. Again, just turn to the calculator to simplify. 0 plus doesn't really make a difference in this case. So I have the square root of 4,096, close parenthesis, divided by negative 32. When I hit enter, t equals negative 2. The second one I can't drop as everything as easily because I have this minus sign. So when you're simplifying, make sure you have a negative in front of your square root. And then square root 4,096, close parenthesis, divided by negative 32. And my other answer is t equals positive 2. Again, negative 2 doesn't make sense, but the positive 2 is the answer. But notice, in either instance, we still get positive and negative 2 for possible solutions. The third and final way of solving it is using your calculator. So we had 0 equals negative 16 t squared plus 64. So what's going to happen is, in y1, we'll type 0. In y2, we'll type negative 16 t squared plus 64. So 0, scroll down, negative 16, instead of t, we'll just use an x squared plus 64, and we'll graph. So in this case, what I'm looking for is two intersection points. I know one of the lines I graphed is y equals 0, so that's going to sit on the x-axis. To double check it's there, you can always go to the table, and you have y1 equals 0 all the way down. That way you know it's graphed. What I'm looking for in this case are intersection points, which are going to be here and here, so I don't need to necessarily move the window or anything so I can see the rest of the parabola. In order to find these intersection points, we're going to hit second trace, 5. Scroll as close as you can to one of the intersection points. Hit enter 3 times. And one of the points is negative 2, comma 0. So if I sketch my graph really quick, do something to emphasize that the other line is right here. Whoops. This point right here is negative 2, 0. To find the other intersection point, start the process over. Second trace, 5. I'm going to scroll as close as I can to the other point. Hit enter 3 times. And I get the point 2, comma 0. So now I can see that x, or t, equals negative 2, and it equals positive 2. Those are my two solutions. Again, we're in story problem land though, so negative 2 doesn't make sense, and positive 2 is my answer. It doesn't matter which method you choose, it's whatever you are more comfortable with. Just make sure you show all your work and show your teacher everything that they need to see.